Notice the gentleman walking around, he's staying put in the middle and he is drawing a circle. So he stayed at the center point as he walked around. So whatever the height of that gentleman was the radius. So let's see what this is wanting us to do. The world's largest coin is a giant gold coin minted in Canada. It has a circumference of 61.9. Remember, circumference is the area all the way around it and weighs about 220 pounds. What is the area to the nearest square inch of the face of this coin? We're using 3.14 for pi. Well, let's go through this and evaluate a couple of things. One, we don't need to know how much is it weighing. The second thing is it's asking us what is the area. So we need to think about what is our area formula. So area equals pi r squared. So we need to think about this. So we know our circumference is 361.9. Circumference is going to be and the formula for circumference is pi 2 times 2 times r. So remember the difference, if we're talking area, we're always talking squared units. So it's r squared, and circumference is 2 times the radius is pi. Well, we happen to know what the diameter is, so we can rewrite this to say circumference is also pi times the diameter, right? Because the diameter is the same as saying 2r. So let's see what we can do. Okay, so we need to find the radius of the coin. So by doing that, we say, well, the circumference is 2 times pi times r, which we just wrote. We're going to substitute in 61.9 is approximately equal to 2 times 3.14 equal times r. So if 61.9 equals 6.28 times r, we can divide 61.9 by 6.28 because we need to get this r all by itself. When we do, we get 9.9 is approximately r. So we have the radius of the coin is about 9.9 inches. Now we're going to use our area formula because remember we caught that when we were reading that they want our area. And we remembered that whenever we talk area, we're talking units squared, so our r has to be squared. So here's our formula. We're going to take pi, and we're going to go with the r that we just found up here, and take 9.9 and square that. When we do, we get 98.01 is times 3.14, and we find that approximately 307.8. It asked us to round, so it's getting a little late. The area of the coin is about 308 inches squared. Our magic word is going to be yawn, since that's what I wanted to do and decided to do for you. Okay, so ladies and gentlemen, we saw in our last shot how knowing the diameter will help us find the radius, and that can help us find area. So if we know the circumference and we know diameter, we can find radius, and then we can find the area. So we're going to see some more relations between circumference and an area. So if my radius is 4, then when I go to find my area, I'm going to take 16 times pi because I'm taking r squared. But for circumference, it's 8 pi because I'm taking 2 r's or 1 diameter. Remember, my radius is 4, so my diameter would be 8. Then if I look over here and I have area divided by circumference, I'm going to have my area was 16 pi, and my circumference is 8 pi. And remember, whenever we have a number that's exactly the same over another number, it's going to make that 1. So when I have pi over pi, that actually is 1. So I can ignore that now, and I have 16 over 8. If I simplify that, I get 2 over 1. Let's try some of these. Okay, so I did this one for us real quick, and we see that it's 6 squared is going to be 36, but 6 times 2 would be 12. 36 pi over 12 pi will simplify to 3 over 1. So let's try number 8 together, or the 8 together. Okay, so you don't have to wait on me trying to type or write. I went and did all the little pi symbols that I could get ahead and do. So what is 8 squared? Because that's area, right? Area is going to be squared. It's right, 64. maybe if I can make a 4, right? What is 8 times 2? Because we're looking for the length of the diameter here. It's 16. If I put 64 over 16, what do I find? This simplifies, remember that makes just 1. So 64 over 16 is simplified to 4 over 1. Go ahead and try the last one on your own. Okay, so ladies and gentlemen, this should have been a pretty easy check for you. 10 squared is 100. 10 times 2 is 20. Place 100 over 20. That simplifies to 5 over 1. Now, do you see any kind of patterns happening? Let me pull up a highlighter. Let's go for this blue. And I'm going to give you some suggestions. Look at this column. I could almost speak, right? And this column. What do you see happening between the area and the circumference, the ratio of area to circumference? We have 2 over 1. We could say this is just 2 also. And this is 4. We have 3. We have 6. This is 8. This is 4. This is 10. This is 5. So when we place our area over our circumference as a ratio, we're getting a 2 to 1, right? We're getting that the radius is going to be twice as much as the ratio of area to circumference. So we can predict if we've done our math right. Did I do my calculations right? Because if I have a radius of 32, what are you going to predict my ratio of area to circumference? Oh my goodness, hold on a second, something happened. Okay, let me stick back with the pen. I seem to do better with that. So if I have an area of a radius of 32, what are you going to predict my ratio of area to circumference should be? It should be 16, right? So I could check this, and I could do the math, and when I simplify, I should get 16 as a checking point. Here's a challenge problem. Let's see if we can walk this one backwards. It's telling us that we have our ratio is 11 to 1 for our area over our circumference. So we know that that means our radius needs to be 22. If we know the radius is 22, and I'm just going to, actually let me do this. Then what do I know about my circumference? The circumference is 2 times r, or I could say that it's d, right? Because 2r is a d. So what is this 2r? It's going to be 44. If I put this, I say, oh, I guess that's all I needed to do. I'm sorry, I was trying to make you do more work. So we could write this like this, working backwards from that little piece of information we knew. Okay, this was the last of this video, and it's actually the last of this unit. So thank you very much.